AP Calculus, section 6.4, page 7. All right, looking at this. A new employee performs a job more efficiently each day in such a way that if Y units are produced per day after T days on the job, then his rate of production is proportional to 80 minus Y. The employee produces 20 units the first day of work and 50 units per day after being on the job for 10 days. And a bunch of things to do here. The biggest one is expressed Y as a function of T. Okay, the part that's important here to set that up is that his rate of production is proportional to 80 minus Y. So right there, that tells us his rate of production, dy dt, there's his rate, is proportional to K times 80 minus Y. Now, this is slightly different than what we were doing before when we had Y equals, well, let me back up, dy dt equals ky, then we could jump right to y equals ce to the kt. This is not ky though, this is k times 80 minus y, so we can't make this jump. We have to work through the steps by separating out the variables here. Let's multiply by dt and divide out that 80 minus y. Anti-differentiate both sides. Right hand side clearly kt plus c, that's the easy one. Left hand side, you have to be very careful here when you do this antiderivative. This is the natural log of the absolute value of 80 minus y, but it's negative. It is negative there because if you think about doing a u substitution, u would be 80 minus y, and du would be negative dy. That's where that negative comes from. Also, 80 minus y could be negative if y is greater than 80, but y is less than 80 for all time. That means that this quantity is always positive and we don't need the absolute value bars. So at the same time as I'm going to divide out this negative sign, I'm going to drop those absolute value bars. So we have the natural log of the quantity 80 minus y is negative kt minus c. And then solving here for y, I believe in pre-calculus most of you were taught to take e raised to both sides. And on the left-hand side, that simplifies down to be just 80 minus y. Right-hand side, we have e to the negative kt times e to the negative c. E, 2.71818, blah, 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 raised to any power is just a different constant. So we have 80 minus y equals some different constant c times e to the negative kt. Solving for y, we will have 80 minus c e to the negative kt. Okay, some initial information so that we can start to solve for this. We know at time 0, this guy is expected to make 10, I believe, no, he produces 20 units, so y is 20. Time 0, because that's when he's starting the job, by the end of that day, he's expected to produce 20 units. And subbing in here, then we'll have 20 is 80 minus c e to the negative k times 0. That's all 1. So we have 20 is 80 minus c, or c is 60. Our equation now looks like this. Y equals 80 minus 60 e to the negative kt. I'm going to bring that all the way up here. Y equals 80 minus 60 e to the negative kt. Another piece of information, after being on the job for 10 days, he's making 50 units per day. So when time is 10, y is 50. 50 equals 80 minus 60 e to the negative k times 10. Subtract that 80, gives us a negative 30. Divide out the negative 60. Then to make this side here, this right side, to be just an e to the k, we're going to have to raise that to the negative 1/10 power. And we'll have e to the k is 1/2 to the negative 1/10. All right, now be careful here. When you substitute this back in, this e to the k, we're replacing out this bit, that e to the k, with this 1/2 to the negative 1/10. So we have y equals 80 minus 60, all right, e to the k, 1/2 to the negative 1/10, but then that's raised to the negative t. And finally, this is 1/2 to the t over 10. There we go. That's the answer to part A. Oh my goodness. There's part A. Part B. How many units per day can this employee be expected to produce after 30 days? So at time 30, we'll just plug in y is 80 minus 60 times half to the 30 over 10. 80 minus 60 to the 30 over 10 is 3, half to the third 1/8. And we can simplify here, divide out by a 4. And we have 80 minus 7.5, or 72.5 units. Still in part B, this time, how many units can this guy make after 60 days on the job? So same concept. One-half to the 6th. That's 1 over 64, because 2 to the 6th is 64. And again, simplifying out by a 4, 15/16. So we have 80 minus 15/16, or 79 1/16 units. All right, last bit in here. How many units per day can the employee eventually be expected to produce? And we're going to let him work for forever. We can't substitute in forever into this equation. We can, however, do a limit and let that time get very, very big, of 80 minus 60 to the half, or times half to the t over 10. All right, that's what we're looking for. What is this limit? Well, if we think about what's happening, huge number in here. Huge number divided by 10, still a huge number. Half raised to a huge number power, very small, very close to 0. Very close to 0 times a 60. 0. 80 minus 0 is 80. He can be expected to produce very close to 80 units per day if we let him work for forever. Okay, now the last part here is to put this on your calculator. Oh no, I don't have a calculator with me. Oh yes, I do. Whew! All right, so let's put this mess into your calculator. And we're going to put in 80 minus 60 times a half to the t over 10, x divided by 10. All right, window. X in your calculator is time, and let's let this run for, say, 200 days or so. I like to see my axes, so I'm going to set my axis to be negative 10 to 200. Y in your calculator is going to represent number of units. We know he starts at 20 units, maxes out at 80 units. I'd probably go negative 10 to 100. Graph, and we see something like this. All right, let's just quickly confirm our answers from part B. So let's do a value at 30, and there we go, 72.5 right here. I want to check 60. You don't have to do second calc value again. You can just type the 60 right off the bat, and there it is, 79.0625. All right, now we can't go to infinity, but our window was set all the way out here at 200 days. Let's check 199 days and look how many units he's making. So that upper limit of 80 truly makes sense. The other thing that's going on in here, do you see a horizontal asymptote at y equals 80? And do you remember way back when we were doing limits that the limit as x approaches infinity, in this case t, sets up horizontal asymptotes? So there is a horizontal asymptote for this function at y equals 80. All right, that's the end of chapter 6. Thank you very much.